Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 7 to the power of x is equal to 70. Now we can first start by converting 70 to 7 times 10. So now we have 7 to the power of x is equal to 7 times 10. Now I'm going to divide by 7 on both sides. So now we have 7 to the power of x over 7 is equal to, these two cancel out, so simply just 10. Now, if we have something in the form a to the power of m over a to the power of n, this is simply equal to a to the power of m minus n. So 7 to the power of x over 7, this would be 7 to the power of x minus 1. And now this is equal to 10. So now what we're going to do is we're going to take the log of both sides. So now we have log 7 to the power of x minus 1 is equal to log 10. Now, the power property of logarithm states that I can actually move this exponent here to the front of the log. So now this would be x minus 1 log 7 is equal to log 10. Now I'm going to divide both sides by log 7. So now these two cancel out, and I get x minus 1 is equal to log 10 over log 7. Now, if I add 1 on both sides, I get x is equal to 1 plus log 10 over log 7. So this is our answer. Alright, so in this problem, I have 5x to the power of 5 minus 5x is equal to 0. So, to solve this problem, I'm going to first start by factoring out 5 from 5x to the power of 5 minus 5x. So now I have 5 times x to the power of 5 minus x is equal to 0. Now, I can go ahead and divide both sides by 5. So then these two cancel out. And now I'll be left with x to the power of 5 minus x is equal to 0 divided by 5 is 0. Now, x to the power of 5 minus x, I can simply factor out x from here. So now if I factor out x, I get x times, well, x to the power of 5 divided by x is x to the power of 4. And negative x divided by x is negative 1. So this is equal to 0. And now this is going to give me two equations. I have x is equal to 0, and I have x to the power of 4 minus 1 is equal to 0. So x equals 0, this is already a solution. So now I'm going to go ahead and solve x to the power of 4 minus 1 equals 0. Well, x to the power of 4, that's the same thing as x to the power of 2 times 2. And if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So x to the power of 2 times 2, it's going to go x to the power of 2 to the power of 2 minus 1 is the same thing as 1 squared. So this is equal to 0. Now, if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So in this case, if x squared to the power of 2 minus 1 squared, a is equal to x squared and b is equal to 1. So I have x squared plus 1 times x squared minus 1 is equal to 0. So this gives me two equations. I have x squared plus 1 equals 0, and I have x squared minus 1 equals 0. So for x squared minus 1 equals 0, I can simply add 1 on both sides, and I'll be left with x squared is equal to 1. Now I'm going to take the square root on both sides. Square root of x squared is simply x, so I have x is equal to positive or negative 1, because the square root of 1 is positive or negative 1. So these are two solutions. And now x squared plus 1 equals 0. I'm going to start by subtracting 1 on both sides, so I have x squared is equal to negative 1. Now I'm going to take the square root on both sides. Square root of x squared is x, and the square root of negative 1, this is actually equal to the imaginary number I. So I have x equal to positive or negative I. So these are two more solutions to this problem. So my solutions are x equals 1, x equals negative 1, x equals 0, x equals I, and x equals negative I, or negative I. So these are my 5 solutions to this problem. Alright, so in this problem I have 5 to the power of x is equal to 7. So the first thing I'm going to do is I'm going to take the log on both sides. So now I have log 5 to the power of x is equal to log 7. Now if I have something in the form log a to the power of b, I can simply move this exponent b to the front. So this is going to equal b times log a. So in this case, I have log 5 to the power of x. So I can move x to the front. So now I'm going to have x times log 5 is equal to log 7. Now, to simplify this, the value of log 5, this is equal to approximately 0.8451. Log 5, this is actually equal to 0.6990. And log 7, this is equal to 0.8451. So these are my two values for log 5 and log 7. Alright, so now what I'm going to do is I'm going to first start by dividing both sides by log 5. So then these two cancel out. And now I'm going to be left with x is equal to log 7 over log 5. Now, I know that log 7, this is equal to 0.8451. And log 5, this is equal to 0.6990. So now I have 0.8451 over 0.6990, which is equal to 1.2090. So this is my answer. So now to check, first start with 5 to the power of x equals 7. I know that x equals 1.2090. So I have 5 to the power of 1.2090 is equal to 7. Now, 5 to the power of 1.2090, that's equal to approximately 6.99, so I have 6.99 equals 7. And 6.99 rounds up to 7, so I have 7 equals 7. And because this is right, my solution is right. Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this algebraic equation. Now make sure to stick to the end of the video, where I have 3 bonus problems that are similar to this one, which you guys can try to solve. Alright, so I have x to the power of 3 plus x to the power of 2 plus x plus 1 is equal to 0. So I want to find the value of x. So for my solution, first start with x to the power of 3 plus x to the power of 2 plus x plus 1 is equal to 0. So now, from x to the power of 3 plus x to the power of 2, I'm actually going to factor out x to the power of 2. So now I have x to the power of 2 times, well, x to the power of 3 divided by x to the power of 2 is simply just x, plus x to the power of 2 divided by x to the power of 2 is 1. So I have x to the power of 2 times x plus 1, plus simply all I'm left with is x plus 1. So this is equal to 0. Now, if I factor out x plus 1 from this, I get x plus 1 times x squared plus 1 is equal to 0. So, from here, I get 2 equations. I have x plus 1 is equal to 0, and I have x squared plus 1 is equal to 0. So for x plus 1 equals 0, simply subtract 1 on both sides, these two cancel out. Now I'm left with x is equal to negative 1. So this is one solution of x. Now, for x squared plus 1 equals 0, I'm going to first start by subtracting 1 on both sides. So now these two 1's cancel out, and now I have x squared is equal to negative 1. Well, now I'm going to take the square root on both sides. So now I have the square root of x squared is equal to the square root of negative 1. Now, the square root of x squared, that's simply equal to x. So if x equals square root of negative 1, well, it's actually positive or negative square root of negative 1. And if you guys already didn't know, the square root of negative 1 is actually equal to I, the imaginary number I. So now, if I replace the square root of negative 1 with I get x is equal to positive or negative I. So my 3 solutions to this problem are negative 1, I, and negative I. Negative I. So these are my solutions.